just take a look around you for a second. I bet you're surrounded by stuff made of metal. But have you ever really stopped to think about how we take a simple, solid block of metal and turn it into something super complex and useful? Well, today we're going to pull back the curtain and uncover the secrets of that incredible transformation.
So really, how does a boring block of metal become something like a bridge, a car part, or even just the tool in your hand? Now, you might think the answer is all about melting it down or, carving away pieces. But a lot of the time, the most important method is way more elegant. It's just about squeezing it into shape.
Yeah, that whole process of squeezing and shaping, that's what's known as metal forming. This is where the real magic of engineering starts, and it's how we literally shape the world all around us. Okay, so what exactly is metal forming? Well, at its core, it's all about applying some serious mechanical force to a piece of metal to reshape it. And the key thing here is we're doing this without adding or removing any material. It's all about pushing and squeezing it into a new permanent form. The real magic trick behind all of this is a property called plastic deformation. Okay, think about a rubber band for a sec. You stretch it and it snaps right back, right? That's elastic. But when you apply enough force to metal, it doesn't snap back. It permanently holds its new shape. And that permanent change, that's plastic deformation. And trust me, it's the key to everything we're about to see. But before we can even start shaping anything, there's this huge decision we have to make. Are we going to work the metal while it's hot, or do we do it cold? And this choice, it's not just about what's easier. It fundamentally changes the final properties of whatever we're making. So here's the deal. Hot working, which is done when the metal is literally glowing hot, makes it soft and way easier to shape with less force. On the other hand, cold working, done at room temperature, needs a lot more power. But, and this is a big but, all that extra effort actually rearranges the metal's internal structure in a way that makes it significantly stronger. That's a process called strain hardening. So it's this classic engineering trade-off, right? Do you want it easy to shape, or do you want it stronger in the end? All right, let's see this stuff in action with our first major process, rolling. I want you to imagine a colossal, industrial-strength rolling pin. Got it? Because that's pretty much the basic idea behind one of the most fundamental ways we shape metal. So here's how it works. You take a piece of metal, often red hot, and you feed it between these two massive rotating rollers. The insane amount of compressive force just squeezes it, reducing its thickness and stretching it out. It sounds simple, but it's an incredibly powerful and super efficient way to mass produce metal products. But what's really fascinating is what's happening on a microscopic level. As the metal gets rolled, its internal crystal structure, we call them grains, they get all stretched out. But here's the cool part. When it's hot, those stretched out grains immediately reform into new, smaller, more tightly packed grains. So you're not just changing the shape, you're actually making the metal tougher and more uniform on the inside. And this isn't just a one-and-done kind of thing. A huge ingot is progressively rolled down into more manageable shapes. First, it might become a bloom, then that gets rolled into a smaller billet, or maybe a rectangular slab. Think of these as the basic building blocks that will eventually become everything from steel plates for ships to the rails for our train tracks. And the rollers don't have to be flat either. By using these specially shaped, contoured rollers, we can create all sorts of complex and consistent cross-sections. This is exactly how we get those I-beams that hold up skyscrapers and the rails our trains run on. Rolling is also unbelievably versatile. I mean, look at this process. It's called ring rolling, and it can create these huge, seamless rings with incredible strength. And these aren't just for decoration. They become absolutely critical components in things like jet engines, wind turbines, and giant industrial bearings. Okay, so rolling is fantastic for making long, uniform products. But what if you need a really complex, one-piece shape, like a wrench or an engine crankshaft? Well, for that, we have to turn to a much older, more direct method. And we are talking about forging. This is basically the modern evolution of the village blacksmith hammering away at their anvil. It's the art of shaping metal not by squeezing it through rollers, but by hammering or pressing it into the shape you want. Now, there are two main ways to go about this. Open die forging is a lot like that blacksmith using a hammer and anvil. The metal is just shaped between two flat surfaces. But with closed die forging, the metal is squeezed into a die that has the exact shape of the final part. It's kind of like pouring batter into a waffle iron. The metal has nowhere to go but into that shape. Forging has a ton of specialized forms too. Take swaging, for example. Here, you've got these rotating hammers that just pummel the workpiece from all sides to reduce its diameter or create a taper. It's a super precise way to shape rods and tubes for very specific jobs. And now for what is easily the most common forging process on the entire planet, heading. Every single bolt and screw you have ever seen was made this way. A piece of wire is struck with incredible speed and force to form the head. We're talking billions of these made every single day, literally holding our world together.
So there you have it. We've got these two primary paths: the continuous squeeze of rolling for long products and the discrete, powerful impact of forging for individual parts. And each one is chosen for a very specific purpose. So let's just break it down one more time. Rolling, that's for high-speed, mass production of uniform shapes like sheets and rails. Forging, that's for creating incredibly strong, complex, individual parts. Things that absolutely need to withstand immense stress, like your tools and the components inside an engine. So, why does any of this actually matter? Well, because our entire world is built using these two methods. A car's body panels, that's rolled sheet metal, but its axles and gears, those are forged for strength. From the I-beams in skyscrapers to the tiny little screws holding your phone together, these forming methods are, believe me, absolutely everywhere. So the next time you look at the world around you, whether it's a massive bridge, a simple wrench, or the car you drive, just think about its journey from a raw block of metal. Can you see the evidence now? Was it squeezed and stretched through giant rollers, or was it hammered and pressed into its final perfect shape? It's pretty cool to think about.